I'm Tamiris, an aeronautic engineering student, and I'm going to present my internship project in which the topic was the theme Design and Development of Flight Taxi for Uber and Innovation Implementation using CAD. Before I started development, I was guided to make a Gantt chart where it helps us to plan at the right time so there are no adversities. The urbanization process, which started with the Industrial Revolution in the 18th century, resulted in a high population concentrations in a small number of cities, leading to a high number of combustion vehicles. However, with an ongoing technological revolution, technological innovations impacted to the aeronautical sector, resulting in the development of a new aircraft model called eVTOL, electro-vertical takeoff and landing. In this way, the cities where this new vehicle will be deployed will have their urban mobility changed. With this, the new term urban air mobility was introduced. The goal of this technological innovation is to create a vehicle that is able to transport people in the air in total safety with low noise, no CO2 emissions, and with good performance and range in a practical and fast way through the Uber app found in all smartphones today. Recently, Uber has been testing its vehicle from different aeronautical partners in different cities, being to the United States and one in Australia. Starting with Los Angeles, located on the Pacific Ocean coast in the United States, it showed better results in visual weather conditions, VMC, compared to the other two cities mentioned. Another positive point is about the vertiports, which will be taken about later, which are heavily concentrated in the Los Angeles Central Business District and the Santa Monica-Beverly Hills corridor, suggesting a high potential from travel from these areas. In Dallas, average weather conditions were found to be lower, with higher frequencies of no VFR, visual flight rules, conditions, high winds and vertical wind shear, which may pose potential challenges to AM operations in most seasons. While in Melbourne, Australia, they have a small number of existing heliports. In light of this, they are presumed to include vertiports, considering that most Australian suburbs have no available unbuilt area that can be considered for future construction of the area designed for eVTOL aircraft. With such overflights, space had to be created to support this fast and convenient mobility vehicle. Hence the so-called vertiports, areas designed specifically to advancing air mobility aircraft to take off and land. This space in particular was created because the maintenance of the vehicle under study is easier, as well as that supply, which will be done through the electric grid, not needing to land in large runways in a conventional airport. Also, because of this small size, this transport will be able to take off and land in places such as on top of building, parking lots, shopping centers, or have its own area. Now, about the type of energy that operates in eVTOL, we are talking about propulsion. The electric type propulsion is used, which performs more sustainable actions to the planet, not polluting the environment through gases. Electric propulsion uses electrical energy to accelerate the propeller and produce thrust. Batteries made of lithium are used, as has been standard in developed UAM aircraft. Depending on the weather conditions, drive style and vehicle configuration or the age of the battery, the vehicle can operate for approximately 100-200 kilometers on a single charge. However, the batteries are considered significantly heavy compared to other devices. Finally, talk about the design. Inventor software was used to produce the parts. For the wing and stabilizer, the Epler 169 symmetrical profile was used, which through the XFLR5 program was considered suitable for the flight conditions encountered, such as a high lift and low drag. A pair of wings, 4 propellers, stabilizer, 2 landing gears, and the fuselage were developed. The designed eVTOL is 20.21 feet long, 16.975 feet high, and has a wingspan of 36.9 feet. Here you can see the isometric projections of the urban mobility vehicle. In analogy to the models like the Lilium and the Kitty Hawk Cora, their analysis doesn't differ much. It has a range of 112 miles, a speed of 125 miles per hour, and an altitude of 2,000 feet. According to market studies, an eVTOL can cost on average $600,000. The following chart shows the annual percentage expenditure for the cost preservation of the new means of air transport. 30% for structure costs, 20% for acquisition costs, 15% for maintenance, 14% are storage costs, 12% are energy costs, and 4% are controller and insurance costs. Finally, I want to thank for the opportunity to develop this project in my first internship, where I could develop my skills in CAD, as well as explore the market of urban air mobility, an area that will have much visibility in the coming years. So, thank you very much.